Hello. Do you remember this light from the last mailbag? If you don't, I'll put a link to it up there. This light is one of two that I received, and this one arrived in this box. And as you can imagine by the condition of the box, it doesn't work. So today I'm going to tear it apart to figure out why it doesn't work. Hopefully repair it. But even if I can't, the vendor did give me a partial refund on my shipment, so all is not lost. Not a 50% refund, but something's better than nothing, I guess, especially if I can fix it and get a working light out of it. So the specs on the box say that it's a 60 watt E27, 6500 Kelvin, and the website that I bought it from, well, eBay, the listing, said that it is this version, so I can use it for 120 volts, and I confirmed with the one that's working, that arrived with it, that it is in fact going to work here in North America, as confirmed by its brother here, which does work. And yeah, that is damn bright. So just looking at this quickly, I'm going to pop the cover off one of these lenses. It looks like they're just clipped on in the edges here. Just pop that off if I can. 1, 2 clips, third clip there, and there's a fourth one back there. I'm not sure if you can see or not through the white solder mask, but each of these 4 pedals of the thing has 1, 2, 3, 4, 5, 6, 12 LEDs. The LEDs are in pairs, in series pairs, so these two are in parallel. These two are in parallel, these two, these two, these two, these two, and then each one is in series, and the last trace goes back here to the negative side. I think you can see that there is this huge pad here, which puts this parallel pair in series with this parallel pair. The same thing happens all the way down it. And then 2 wires disappear off into the central bit here. So not much else to be learned out there. And I'm assuming that those, I don't know, if you were designing a mains voltage LED light, would you put all these leaves in series? Probably. Well, we'll open up this central bit here and find out. There's 4 screws on the back of it. They're all self-tapping screws, but they come out fairly easily. Now, is that... okay, I guess right. So those are just held in there by friction, right? And yeah, it looks like they are all in series. Okay. And the wires to those seem to be intact. Oh, I can already see the source of my problem. Can you see that wire down there that's not actually connected to this thing? Well, that should, maybe, hopefully, be an easy repair. That's the one that goes to the outer shell of the connector, which is crimped on. Okay. So I may have to do some arthroscopic surgery down in the bottom of there, maybe. Let me just figure out. In the meantime, before I do that, let's look at this little driver here and just see what it is. To make it easier to get it out, I'm going to take this other center pin out. The center pin is just sort of a rivet that is trapping the live wire in there. Need something else to pry that out of here. Like I said, I want to try and repair this. I'm going to be a little bit gentle, more gentle than I typically am when I'm doing a teardown. What you can see there is the wire going to the center pin, and that frees the driver board. So let's take a closer look. After spending a few minutes with this thing, it is a very, very common type of power supply. If you've watched Big Clive or Diodes Gone Wild or any other channel that takes stuff apart, you will have seen this thing dozens and dozens of times. This one takes some shortcuts. So anyway, here is the line input. Here's the neutral input. Notice the wire is not going to the neutral input. There is a fuse marked on there, but this is connected to beyond the fuse, so no fuse. Also, we have a position for a transient voltage protector there, which is absent. Other than that, it's very standard and very normal. Bridge rectifier, smoothing capacitor, power supply chip, which I couldn't find the part number. Well, I could find the part number, but I couldn't find it online. Current sense resistor, inductor, diode on the secondary-ish side, even though it's not a transformer, but on the DC side, basically, a diode, smoothing capacitor, and a little tiny resistor there. Well, small but big value in parallel with this capacitor and in parallel with the diodes, and then it just goes out to all the LEDs. And when you draw it out, it looks like this. So we have the line of neutral coming in. We have a bridge rectifier, which I'm too lazy to draw properly. Positive and negative voltage, the big smoothing capacity, 15 microfarads, 450 volts. Our chip, DP9902B. Google has let me down on that one, but there are lots of little 8-pin power supply chips. This thing is only using, four of them. Positive voltage, negative voltage, the current sense resistor, in this case 1.3 ohms, and then, did I say 4? 5. And then 2 pins parallel together, which go to the inductor. And then there's the capacitor after it, which is 400 volts, 2.2 microfarads, like that. There is the discharge resistor across that capacitor. Here is the diode, which creates DC out of this. And then the positive voltage goes through all these 24 pairs of LEDs and returns back to the negative side through here. So essentially, this guy will be monitoring the current through this current sense resistor. It'll have a MOSFET in here switching this high and low, or on and off, or open and closed. When it's switched to ground, there is current flowing through the inductor. When it senses the current is high enough through the current sense resistor, it will open up. The magnetic field in here will collapse back through the diode, charging the capacitor and powering the LEDs. Very, very common. That's only part of why we're here today. The other part is to try and fix this thing. And that's going to be a little bit of a mechanical challenge, because I can't really take this connector off without damaging it. It's crimped in a bunch of different places around here. And I don't really want to destroy it because, like I said, I want to use this. I'll try and reach down in here and just tin this wire to start with. I think that worked. Next, I'll take my pre-tinned piece of extending wire, which is just something that I salvaged. This is a nice flexible silicone jacketed wire, though. I'll take that and try and reach down in there and solder that on. That actually worked. Cool. Now drop a piece of heat shrink down into there just to both strengthen it and also insulate it. Yellow is not important, it just needs to be the right size to get down in there. Now just shrink that down so it doesn't cause any trouble. That'll also reinforce the joint a little bit too, just to make it stronger, but mostly I just don't want it being electrically unhappy. And now I think it's just a matter of gobbing it onto the circuit board where the other wire fell off. And I think we are good to go. Next step, to just feed this back down through the hole at the bottom and push this little tack into there to hold it in place. That seems kind of cheesy to me, but that is very, very common, so we'll let it slide. Now that's all in there. Let's just live dangerously and see what happens. Place your bets. Power bar's turned off. Plugged in. Right. If this works, we should see light over here. Ha-ha! We have success. That's excellent. One thing that I want to check while I've got this thing open is the voltage across these panels, remembering that the 4 of them are in series. So this panel is about 35.5 volts. So divide that by the 6 series, that is about 6 volts. So these are 2 volt LEDs each. Can I actually measure an LED? Yeah, so basically 6 volts across each LED. So these are, I guess, 2 chips in a single LED package. One other thing that I should check, but I'm going to put this thing together first, then retest it. And I want to check the overall current and wattage just to see if the listing is lying to me about it. Hang on for just a moment. So with the light all back together again, we'll just run it into the knockoff kilowatt meter here and see what kind of wattage this thing is pulling. That's the easiest way to do this. So it's only drawing about 17 watts. That's 222 milliamps. And the power factor is 0.6, which, yeah, that's, for that kind of a power supply, that's not unexpected, I guess. But that is, so it's settled down to 13 watts now, but that's far from the, what did the listing chart promise me anyway? Actually, the listing didn't say, but the box called it a 60 watt light. The options are 30, 40, 45, and 60 from this manufacturer. On the other hand, it is plenty bright the way it is, and for a garage light, it's throwing lumens, which is all I really care about. Well, and it works now. Simple repair, happy. Anyway, that's yeah, that's all I got for you today. Nice simple repair, quick teardown. All in all, I'm relatively pleased with these things for cheap, so what's there not to like? Thanks for watching. Questions and comments down below as usual. I'll talk to you later. Oh, and for anyone curious, the beer tonight has been Night Owl La Chope Stout from La Chope Brasserie in Winnipeg. Just a nice Irish-style beer from a French brewery in the middle of Canada. What's not to like about that?